In this video, we're going to talk about how to graph sine and cosine functions. So up to this point, we haven't really talked about sine and cosine as pictures. We've just talked about them more like numbers, like we put a number in and we get a number out. So now we're going to actually talk about how do we represent these things as pictures. So the first thing we're going to define is a periodic function. So sine and cosine are both examples of periodic functions, and these are just functions whose graph repeats itself again and again. So like when you draw these pictures, they go on infinitely, but we're only going to focus on one tiny part of it, because that part that we focus on would just be copied and pasted like to infinity. So when we talk about graphing functions, there's a few important words we need to talk about. First of all, the domain is the x values. So in the case of sine and cosine, these are going to be the angles that we plug into the function. The range is the y values. So these are going to be the values of the trig ratios that we get out of the function. And then we also have what's called the period, which is the length of one repetition. And then finally, when we talk about sine and cosine specifically, we talk about something called the amplitude. So when we graph these, they're going to look sort of like waves, and the amplitude is the height of the wave. And so you can either measure this from the midline to the top or the midline to the bottom. And we'll talk about what the midline means in a little bit. So first of all, let's talk about the standard sine function. So when we write the equation for sine, we write it as y is equal to sine of x. So that is how we write the most basic sine equation. And we kind of talked about the domain and range already, but let's just refresh your memory. So the domain of the sine function is negative infinity to positive infinity, and that's because we can plug in any angle into sine of x and get out a value. But the range has to fall between -1 and 1, because remember on the unit circle, the smallest value that we can get is -1, and the biggest value we can get is 1. And then our amplitude of the sine function is 1. Okay, so let's draw what the standard sine function looks like. So when we draw this, we start by labeling our x and y axes. So the way we're going to label the x-axis is we're going to draw 4 tick marks along the axis. So we're going to start at 0, and then we're going to draw one all the way out here and label it 2 pi. We're going to draw one in the middle and label it pi, and then we're going to draw one in the middle of 0 and pi, which is pi over 2, and one in the middle of pi and 2 pi, which is 3 pi over 2. So anytime you draw a sine curve, you will have, I guess there are 5 tick marks if we include 0. You're going to have these 5 basic tick marks. It's just when we transform the sine function, they might take on different names. So what I'm going to do is I'm going to repeat these tick marks on the negative x-axis as negative numbers. So we have -2 pi, -pi, -pi over 2, and then -3 pi over 2. Okay, so that's our x-axis labeled. Now our y-axis is going to contain the amplitude. So we're going to draw a tick mark for +1 and a tick mark for -1. Okay, so that is what the labels should look like on your x and y axis for any time you graph a sine function. Although, like I said, when we get to transformations, they might just have different names. So when we graph sine, we put a point at 0, 0. And then what we're going to do is we're going to create a wave working our way along the key points. And so I'll show you what I mean by this. So from that initial point, we're going to go up to the top and graph a point that's even with the 1 and the pi over 2. And then we're going to go back down to the middle. So we're going to go back down, and pi is going to be on the x-axis. And then we're going to work all the way down to the bottom to -1 at the next key point, and then we're going to go back up to the middle. So now you can see that I've created this sort of waving shape. And so we draw it like this, and we include an arrow at the end just to say that the graph does in fact go on forever. It's just we're focusing on one little part. So I can continue this into the negative direction. So instead of going up, I would just go down and sort of continue the wave like this. So we go down to the bottom, back up to the middle, all the way up to the top, and then back down to the middle. So then if I connect the dots with a nice smooth curve, we would have something that looks like this. And notice I'm going to draw an arrow on this side as well, just to again say that this goes on to infinity. Okay, so this is the basic graph of sine. Now let's label some parts of this graph. So the x-axis is what we call the midline, because it's in the middle of the graph. So you can see like it's sort of that middle ground of the graph. So like it's not the top, it's not the bottom, it's right there in the middle. The amplitude is this height here. So from that top value of 1 down to the middle is our amplitude. And I'm just going to remind you that it equals 1. And then also a period is going to be this length here. So basically if you look at the region of the graph from 0 to 2 pi, so maybe let me highlight this. So if we look at this area of the graph right here, you'll notice that if we take this and sort of copy and paste it along the x-axis, we'd end up with that negative part as well. So this is what we call that that length of one repetition, which is the period. So in this case, one period has length 2 pi. Okay, so that's the sine function. The next one we're going to talk about is the cosine function, which is really similar. So first of all, the way that we write the cosine function is we say y is equal to cosine of x. And our domain and range, if you remember from the previous section, are actually the same as the sine function. So we still have a domain of all real numbers, and we have a range of -1 to 1. And so you might be able to guess that our amplitude is also going to be the same. So our amplitude of cosine will be 1. So now let's graph the basic cosine function. So just like with sine, we're going to have those same labels along our x-axis. So we're going to have 2 pi, pi, pi over 2, and 3 pi over 2. And then in the negative direction, I'm going to write those as well. So we'll have -2 pi, negative pi over 2, and then -3 pi over 2. And then just like with sine again, since our amplitude is 1, we're going to write a +1 on the y-axis and a -1 on the y-axis. So you might be thinking, well, this looks exactly like sine. And you would be right. It's not super different, but it is a little different. So we're going to talk about the difference now. So with sine, remember that when we started graphing, we started at the midline. So we started at that point 0, 0. However, when we graph cosine, we're going to start at the top. So our first point is going to be at the point 0, 1. And we're going to work our way down. But we're going to continue that same sort of wave shape that we did for sine. So we're going to work down to pi over 2. All the way down at that key point of pi, back up to the midline, and then back up to the top. So if we connect the dots here, we get a shape that looks like this. So again, it looks really similar to sine, but it's a little bit different. So if we continue this shape in the negative direction, we'll go down to -pi over 2, all the way down at -pi, back up to the midline at -3 pi over 2, and finally all the way back up at -2 pi. So then if I continue my shape, we get a wave that looks like this. So now let's label the parts of this graph again. So once again, our midline is the x-axis. our amplitude is going to, again, be the height of the wave. So we have from the top to the midline, that's going to be our amplitude, and that's equal to 1. And then the length of the period is, again, this part of the graph from 0 to 2 pi. So maybe I should highlight 1 period again for you. So you notice if we take this part that I'm highlighting and we were to like copy and paste it along the x-axis, we'd have those repeating segments of the graph. So 1 period, again, has length 2 pi. Okay, so just to reiterate, sine and cosine look very similar. They have the same domain, the same range, the same amplitude. The main difference is that we just start graphing them in different places. So what you could say is that sine and cosine are related simply by a horizontal shift. So you might remember from a previous math class that horizontal shift just means that we take the graph and we move it along the x-axis by some number. And so you might notice that if we take sine and we basically back it up, pi over 2, it would look exactly the same as cosine. So I think that's important enough to actually write a little note about that. So sine and cosine, so sine of x is just cosine of x shifted by pi over 2. And that's why these graphs look so similar. Okay, so the next thing we're going to talk about is if we actually take these graphs and transform them in some way. So in a previous pre-calculus or college algebra course, you probably talked about transformations, which include like your vertical shifts, your horizontal shifts, stretches, shrinks, and reflections. So we're going to talk about how to do that with sine and cosine graphs. So the most important thing when you're talking about transformations of sine and cosine are these two general equations here. So notice they look like our initial equations that we had, y equals sine of x and y equals cosine of x, but we're adding all of these different numbers in that do different things. So we're going to talk about what each of those does. So first of all, our amplitude is going to be the absolute value of that number a in the equation. So this is always going to be a positive number. Okay, the vertical shift comes from the letter d. So if d is a positive number, then the graph gets shifted up d units. And if d is a negative number, then the graph gets shifted down d units. Okay, so when we talk about that vertical shift, that gives us a maximum and a minimum value. So maximum is just that value at the top of the wave. So the way that we get that is we just take that vertical shift and we add the amplitude to it. And the minimum value is that y value at the bottom of the wave. So the way we do that is we just start at the vertical shift, which is related to the midline. So maybe I should make a little note of that. And we're just going to take away the amplitude. So you can think of the maximum as the middle going up to the top, and the minimum as the middle going down to the bottom. All right, and then the way we find the period is we start with the original period, and then we divide by that stretching factor in the equation, which we call k. So we're going to take 2 pi divided by the absolute value of k. And so again, the period will always be a positive number because it's a distance. So it's just a distance from the length of that repeating part of the graph. Okay, and then when we talk about horizontal shifts with sine and cosine, we give it a special name called a phase shift. So this is really just a horizontal shift. But in your homework, you'll see this fancy name of phase shift, so I want you to be familiar with that. So the rule for this is if that letter B in the equation is positive, then we go right B units. And if B is a negative number, then we go left B units. So sometimes this can confuse people because you notice in the equation that we have negative signs on B to begin with. Okay, so when I'm saying B is greater than 0, actually what's going to happen is you're going to see a negative sign in the equation. And when B is less than 0, you're going to see a positive sign in the equation. So with those horizontal transformations, they sort of do the opposite of what you think. Okay? And then the final transformation we're going to talk about is reflections. So this is where sine and cosine being odd and even kind of give us a few special rules. So because sine is odd, let's refresh ourselves what that means. So sine is odd means that sine of negative x is equal to negative sine of x. So let's think about what this means in terms of reflections. So if you've talked about reflections in the past, you might remember that putting a negative sign on the inside of a function is reflecting over the y-axis, and putting a negative sign on the outside of the function reflects the graph over the x-axis. So if we take this equation that we wrote down and put it into words about reflections, what we're saying is a y-axis reflection is the same as an x-axis reflection. And so one other thing we can get from this is since a y-axis reflection and an x-axis reflection are the same, what happens if we do both to a function? So what happens if the function has both a y-axis reflection and an x-axis reflection? Well, since they're the same, and I hope you would agree that if we reflect something over the x-axis twice, it would undo itself. Same as if we reflect over the y-axis twice, it would undo itself. So if these two things are the same, and suppose we applied both reflections to the graph, then what would happen is the reflections would cancel each other out. So we're going to make a little note of that as well. So applying both reflections results in no change. But that's only for sine because sine is odd. So the next thing we're going to discuss is what does it mean for cosine to be even? So once again, let's refresh our memory on what even functions are. So cosine is even means that cosine of negative x is equal to cosine of x. So now let's think about again what this means in terms of reflections. So when we put the negative inside of the function, that's a reflection over the y-axis. And on the right side, when we don't have a negative sign at all, that's just our normal function. So what this is saying is that a y-axis reflection is the same as no reflection at all. Okay, so that's the special rules with sine and cosine being even and odd. So now let's just discuss in general the rules for reflections. So in the equation, the reflections are going to be determined by A and K. So if the number A in your equation is positive, then you won't have a reflection. So no reflection. However, if A is negative, then we get an x-axis reflection. And so just to give you an idea of what this means, suppose that this line is our x-axis. That means we're taking our graph and flipping it this way. On the other hand, if that number k in your equation is positive, again, we have no reflection. However, if k is negative, then we have a y-axis reflection. And just a little picture for you to reference, suppose that's your y-axis. That would mean that you're reflecting this way across the y-axis. Okay, so that's all of the rules for transformations. So I know that's a lot, but we're going to go through some examples. And also, if you're interested, when you see this note right here, so what I've done is I've created a file on Moodle with all of the trig functions. And what you can do is you can explore what do these values of a, k, b, and d have on the standard graph. So when you open up the file, you'll see all the functions at once. But what you can do is you can turn the different functions on and off, and you can drag the sliders back and forth to change the values and just kind of see what happens to the picture. So that might help you remember sort of what these transformations do. Okay, so finally, let's get to some examples. So I know that was a lot of theory, but hopefully these examples will tie everything together and make it make sense. So the first one we're going to graph is y equals -2 times the cosine of 1/2 x. So when we start to do these, we're going to write down a lot of information. However, when you get to a test, you should be at the point where maybe you don't have to pick out a, k, b, and d anymore. Maybe you can just skip to some of the information about the graph. So like a typical test question, I might ask you to find certain things over here and then have you graph the picture. So let's pick out a, k, b, and d. So a is the number that's multiplied by either sine or cosine. So in this case, a is going to be -2. K is the number that's multiplied by x. So in this case, k is going to be +1/2. And we don't have any numbers added to x or added to cosine, so b and d are both going to be 0. So this one's a little bit simpler to start out with. So let's translate these values into all of the information about the graph. So a, remember, tells us the amplitude, except we're going to make it a positive number. So it's going to be 2. The vertical shift comes from the letter d, but d is equal to 0. So we have no vertical shift because d is 0. Your maximum, we start at the midline, which we have no vertical shift, so the midline is going to be 0 plus our amplitude, which is 2. And the minimum, we're going to do 0 minus the amplitude, which is -2. The period, we start with our initial period of 2 pi, and we divide by that value of k. So 2 pi divided by 1/2 gives us 4 pi. Our phase shift comes from the letter b, but we don't have a phase shift because b is 0. And finally, we're going to have an x-axis reflection because a is a negative number. So I'll just make a little note of that. Okay, so that's all of the information that we need to pick out about our function. So now let's draw the picture. So we're going to graph one period. And in your homework, they might ask you to graph 1 period, they might ask you to graph 2 periods, so just be aware of the directions. And my other suggestion would be to graph each of the homework problems on paper, as well as actually answering the question in WebAssign. And the reason for this is when you get to a test, I'm not going to give you a multiple choice graphing question. You will be expected to graph these graphs by hand. However, WebAssign does not have that capability, so your homework questions will be multiple choice, but my advice is practice what we're doing here in the notes, practice graphing each of those by hand, and I'll probably include some extra practice for this section as well with my handwritten solutions so that you can get an idea of how I want that to look. So the first thing we do when we graph a sine or cosine function is we label our axes. And the way we do this is we start by labeling the x-axis based on the length of the period. So the period is 4 pi, so that tells us that we're going to start our x-axis at 0 and end at 4 pi because we have no horizontal shift. So our period is just going to go from 0 to 4 pi, and so I need to find the point in the middle, which is 2 pi. Then I need the two middle points of these intervals, so we have pi in the middle of 0 and 2 pi, and 3 pi in the middle of 2 pi and 4 pi. So that's the label on my x-axis. Now my y-axis I'm going to label with the amplitude. So the maximum value we got is 2, so I'm going to put a label as 2 and a label as -2 for the minimum value. So now I have my x-axis labeled, my y-axis labeled. My next step is to actually graph the points. So we do need to take into consideration that we have this x-axis reflection. So if you remember, the initial graph of cosine would have started at the top, so we would have had a point at 2, but since we're reflecting over the x-axis, we're going to draw our point at -2 instead. So what we do is we start at that first key point of 0, and our y value is going to be at that minimum of -2. And then instead of working down, like in the original cosine graph, we're going to work our way up. So we're going to go up to our next key point on the midline. Then we're going to go all the way up to the top at our third key point, back down to the midline, and then back down to the minimum. So we get this wave shape like this. So the next thing you should do is connect the dots with a smooth curve. So don't make them straight lines. Make sure that you try to make them as rounded as possible. And then make sure to draw 2 arrows on each end. So this is the completed graph of one period of our function. Okay, so notice everything we did. We had x-axis labels. We had y-axis labels. We graphed the key points. We connected with a smooth curve. And we drew arrows on the ends. So it's a lot to think about when you first start graphing these pictures, but the more you practice, the more it should be routine to you. So this is all of the stuff that I would expect to see on a test question. So let's try another example. So in this next example, we have y equals 2 times the cosine of 3x plus pi. So this time, our question's a little bit different because we have something added to the inside. We have pi added to the inside. So when you see an equation in this form, the first thing you should do is factor out this 3. So the way we do that is we can write this as 2 times the cosine of 3 times x plus pi over 3. So the reason we do this is because the way it stands in this original form, our horizontal shift is sort of disguised. So the way we undisguise that is we factor out the 3, and that tells us that our horizontal shift is actually going to be pi over 3. So it's very important that when you see an equation written like that, the first thing you should do is factor out that k number. So now let's pick out all the numbers in this equation. So a is the number multiplied by cosine, so a is going to be 2. K is the number multiplied by the inside, which is 3. B is that horizontal shift number, so because we have a plus pi over 3, B is actually going to be negative pi over 3. And then D is the vertical shift number, but we don't have anything added to cosine, so D is still going to be 0. So now let's translate these numbers into all of the information about our function. So the amplitude comes from the letter A, so our amplitude is 2. Our vertical shift, we still don't have one because D is 0. Our maximum is going to be the midline plus the amplitude, so we have 0 plus 2 is 2. Our minimum is the midline minus the amplitude, which is minus 2. And then the period, we're going to take 2 pi and divide by k, which is 3. So our period is just 2 pi over 3. The phase shift we get from b. So b equals negative pi over 3 tells us that we're going to go left pi over 3. And then finally, we ask ourselves if we have any reflections, which k is positive as well as a, so there are no reflections on this graph. So as a note, I'll just say a is greater than 0 and k is greater than 0. Okay, so that's all of the information about our function. So now we can translate this into a picture. So because we have a phase shift in this function, the first thing I'm going to do is figure out how I should label my x-axis. So if we didn't have a phase shift, we would have the following key points. So we know we're going to have 5 different values, and we know we normally would start at 0 and go the length of the period. So we would have 0 to 2 pi over 3. So let's figure out what these would be. So the value in the middle of 0 and 2 pi over 3 is pi over 3. And then the number in the middle of 0 and pi over 3 is pi over 6. And then the number in between pi over 3 and 2 pi over 3 is pi over 2. So if we did not have a phase shift, these would be our 5 labels on the x-axis. However, we want to shift each of these left pi over 3. So to get our actual labels, we're going to subtract pi over 3 from each of these key points. So I'm going to draw 5 new blanks, and I'm going to subtract pi over 3 from each of these numbers. So 0 minus pi over 3 gives me negative pi over 3. Pi over 6 minus pi over 3 gives me negative pi over 6. Pi over 3 minus pi over 3 gives me 0. Pi over 2 minus pi over 3 gives me pi over 6. And finally, 2 pi over 3 minus pi over 3 gives me pi over 3. So the way I'm going to label my x-axis are with these new key points in the second row. So I'm going to have 0, pi over 6, pi over 3, negative pi over 6, and negative pi over 3. And then my y-axis, I'm going to label with the maximum and minimum values again. So I'm going to have a tick mark at 2 and a tick mark at negative 2. Okay, so now I have the labels for the x and y axes, and now I can start to graph the key points of the graph. So we don't have a reflection, so we're going to start at our first key point of negative pi over 3, and we're going to start at our maximum value. So this point is going to be at negative pi over 3 comma 2, and then we're going to work our way down. So at the next key point, we're going to be at the midline, then we're going to go to the minimum, back up to the midline, and then back up to the maximum. So we can connect this with a smooth curve. Notice I don't have any pointy edges. So we have our smooth curve, and I draw 2 arrows on the end. So that is the graph of 2 times the cosine of 3x plus pi. Now for our next example, we're going to work on some sine functions instead of cosine. But it's the same sort of process. So the first thing we're going to do is just pick out our letters a, k, b, and d. So a is the number multiplied by sine. So this is negative 4. K is the number multiplied by x. So we have negative 3. B would be the number added to x, but we don't have anything added to x. So b is just going to be 0. And finally, d is that number that's added to sine. So we haven't seen d yet. This is going to be this number negative 2. So you might see it written like this, or another way that you might see it is if we wrote the function like this. So that d value could be either at the back of the function or at the front of the function. You know that it's a d value because it won't be in the parentheses with sine. Okay, so let's take a, k, b, and d and translate it into our information about the graph. So our amplitude is going to be 4. Our vertical shift is going to be down 2 because d is equal to negative 2. So this time, for our maximum, we're going to start at our midline, which is negative 2, and we're going to add 4. So our maximum is going to be 2. And for our minimum, we're going to start at the midline and subtract 4. So for the minimum, we're going to get -6. For the period, we start with our initial 2 pi and we divide by the positive value of k. So our period is 2 pi over 3, just like the previous example. Our phase shift, we do not have one because b is 0. And then finally, our reflections, we have an x-axis and a y-axis. So x-axis is because A is negative, and y-axis is because K is negative. So we do have 2 reflections. However, if you remember on the first page of the notes, when we talked about reflections, we said that there are some special rules with sine and cosine. So sine was an odd function, which made its 2 reflections the same thing. So like whether we reflect over the x or the y-axis, it makes the graph look the same. So remember we made that note about when we have 2 reflections on a sine graph, it's like we didn't reflect at all. So we're going to make a little note about that. So 2 reflections is the same as no reflection. So when we graph our picture, we're not going to see a reflection at all. Okay, so this is all of our information about the graph. So let's go ahead and get our labels. So we don't have a phase shift, so we're just going to assume that we have our normal labels. So we're going to start at 0 and go to 2 pi over 3. And then I'm going to find the point in the middle, which is pi over 3. And then the 2 points in the middle of those, which are pi over 6 and pi over 2. And so those are my x-axis labels. My y-axis labels, I'm going to have my maximum, which is 2. Let's see, I'll put the 2 about right there. This time I'm going to have to label my midline because we need to know where that is. And I need to label my minimum. So we're going to have 3 labels on the y-axis this time. We're going to have our maximum, our midline, and our minimum. And what I like to do is at that midline, I like to draw a dotted line because that helps me keep the graph neat. So when you do this, this is going to help you keep all those points in a straight line, just as if you were taking that x-axis and just shifting it down. Okay, so this is everything we need on the graph. So let me just make an extra note. So dotted line is midline. Okay, so let's graph our key points. So we're going to start at our first tick mark on the x-axis, but we're going to start at the midline because we have a sine graph. So we're going to put our first point at -2 on the y-axis. And then for our next point, since we don't have a reflection, we're going to work our way up to the top at the next key point. Then we're going to go back down to the midline, down to the minimum, and back up to the midline. So then I can connect these points with a smooth curve and draw the arrows on both ends. So then that is my graph of the function. Okay, so we'll do one more example where we tie everything together. So this example, we're going to have basically everything you can possibly have. We're going to have a vertical shift, a horizontal shift. So we're just going to have everything. So let's see what we can do with this. So our function is y is equal to 1 minus 4 times the sine of 2x minus pi. So remember, the first thing to do when you see something like this that's going to result in a horizontal or phase shift, you want to factor out that number next to x. So the first thing we're going to do is rewrite our equation as 1 minus 4 times the sine of 2 times x minus pi over 2. And now we can pick out all 4 of our letters. So a is going to be -4, k is going to be 2, b is going to be positive pi over 2 because we have a negative sign in our equation, and then d is going to be positive 1. So let's translate those 4 letters into the information about our graph. So the amplitude is 4, the vertical shift is up 1, the maximum is going to be 1 plus 4, which is 5. The minimum is going to be 1 minus 4, which is negative 3. The period is going to be 2 pi divided by 2, which is pi. The phase shift, we're going to go right, pi over 2. And then finally, we have a reflection on the x-axis because a is negative. Okay, so that's all of our information about the graph. Now we need to translate this into a picture. So once again, because I have a phase shift, I'm going to figure out my key points on the x-axis down below. So our original points, we're going to get from the length of the period. So we start at 0 and we go up to pi. The point in the middle of 0 and pi is pi over 2. And then the midpoint of that first half is pi over 4. And the midpoint of that second half is 3 pi over 4. So now to figure out my new x-axis labels, I'm going to add pi over 2 to each of these points. So we have 1, 2, 3, 4, 5. So if I add pi over 2 to 0, I just get pi over 2. If I add pi over 2 to pi over 4, I get 3 pi over 4. If I add pi over 2 to pi over 2, I get pi. If I add pi over 2 to 3 pi over 4, I get 5 pi over 4. And if I add pi over 2 to pi, I get 3 pi over 2. So this is how I'm going to label my x-axis. So I'm going to extend this just a little bit because this one is sort of shifted to the right. So I'm going to draw my 5 tick marks at pi over 2, 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2. And then I'm going to label my y-axis. So I need the maximum, the midline, and the minimum. So my maximum is 5, my midline is 1, and my minimum is negative 3. So again, I'm going to draw a dotted line at that midline. And then now I can graph my key points. So since we're graphing sine, we're going to start at the midline at our first key point. So we're not going to start at 0. We're going to start at that pi over 2 tick mark. And if you want, you can draw another dotted line just to remind yourself to start there. But that vertical one's not necessary. I would recommend for sure the horizontal one. But the vertical one you don't have to do if you don't want to. So since we're reflecting over the x-axis, instead of working up to the maximum, we're going to work down to the minimum, back up to the midline, then up to the maximum, and back down to the midline. So our graph looks like this. So we connect our points with a smooth curve, and we draw an arrow on each end. So that one was complicated, but hopefully since we worked through the slightly simpler examples, we're able to put it all together in this last example. Okay, so the last thing we're going to talk about in this section is we're going to go backwards. So we've been given equations and expected to draw the graph, but what if I gave you a graph and expected you to find the equation? So in this next example, we're going to determine the amplitude, midline, period, and an equation involving the sine function for the graph shown below. So the way I would recommend doing this is just draw a bunch of lines all over your picture. So the first thing I would do is draw a line at the top, draw a line at the bottom, and determine how far that is. So our first line is at -1. And our other line is at -5. So this whole distance here is just 4. So if we want to find the midline, we need the number in the middle. So if I draw another line at -3, you'll notice that I split that graph in half. So my midline is at y equals -3. So notice we're asking for a midline, which means we need to write the equation of a line, and the way we do that is y equals -3. Okay, now that I know the midline, I can find the amplitude. So the amplitude is basically the distance from that midline up to the top or the midline down to the bottom. So if our entire distance is 4, then the amplitude must just be 2. And then I can find the period. So the period, remember, is that repeating distance along the x-axis. So now I'm going to draw a couple more lines. So maybe I start the period at 0 and I ask myself, well, where does the graph start to repeat itself again? And your answer might be at 4. So the period that I'm looking at is this area in here. Okay, so the length of the period is 4 because that's basically the width of this box that I've drawn around the function. So now we've found almost everything they've asked for, the midline, the amplitude, and the period. Now we need to turn this into an equation. So let's start by writing our general form. So we have y is equal to d plus a times the sine of k times x minus b. Okay, so our job is to figure out the 4 letters D, A, K, and B. So D might be the easiest one to find because we already know the midline. So first, D is equal to -3 from the midline equation. Okay, next, the next easiest one to find might be A because A just comes from the amplitude. So A is 2 and that comes from the amplitude. Now, the hardest one to find might be K. So remember the way that we find the period is we take 2 pi and we divide by K. So we can find K by subbing in that value for the period, which is 4, and then solving that equation for K. So I can multiply by K on both sides, so I get 4K is equal to 2 pi, and then I can divide by 4. So we have K is equal to 2 pi over 4, which is just pi over 2. And then finally, I need to consider the letter B. So fourth, B is just going to be 0. So if I look at where I've drawn this box, maybe I'll switch colors. So if we look at this red box, I'm starting at 0 and I'm ending at that length of the period. So I don't have any horizontal shift on this graph. So I'm just going to make a note of that so you can go back and reference. So no phase shift. Okay, so I've found all the letters in my equation. So to write the final equation, I just need to sub them all in. So I can substitute -3 for D, +2 for A, and then I have the sine of pi over 2 times x because B is 0. So this is my final equation for the graph. So that might have been a little confusing, so let's try one more with cosine. So in this next example, we're going to determine the amplitude, period, and midline again, but this time the equation is going to involve cosine for the graph below. So once again, the first thing I would do is figure out how tall this graph is. So I might draw this first line at the top, which is at 2, and I'm going to draw the line at the bottom, which is at -4. So the distance from 2 to -4 is just 6. So the midline must be 3 units from either the top or the bottom. So where is that? Well, that's just at -1. So that's my midline at -1. So we'll go ahead and make a note of that. So the midline is y equals -1. And the amplitude is just going to be 3 because if the total height of the wave is 6, and for the amplitude we just want the middle to the top or the middle to the bottom, it's just going to be half of that. So the amplitude is 3. And then finally, we can find the period by sort of considering that horizontal width again. So let's start by drawing a line at 0 and asking ourselves, well, where does the graph start to repeat itself? So we started at the top, and so we want to see where it reaches the top again. So that's going to be at that pi. So this is the box that we're sort of looking at. Oh dear. Okay, we're not wanting to highlight. Come on, there we go. Okay, so that's the period of the graph that I'm looking at. So the period goes from 0 to pi, so the length of that is just pi. Okay, so I found the midline, amplitude, and period. The next thing I'm going to find is the equation. So once again, let's start with our general form. So we have d plus a times the cosine of k times x minus b. So once again, I need to find d, a, k, and b. So d, once again, comes from the midline, so that's just -1. A comes from the amplitude, which is just 3. The period we can get by doing 2 pi over k, and we know the period is pi, so if we say pi is equal to 2 pi over k and then solve for k, we get k is equal to 2. And then finally, again, we can think about b, but we find that it just equals 0. Because if we look at our graph, our period started at 0 and ended at pi. So we know that our traditional cosine graph with no phase shift starts at 0 and ends at the length of the period. So once again, we have no phase shift, so b is just 0. So the final thing I can do is just sub all of these numbers into the equation. So we have y is equal to -1 plus 3 times the cosine of 2x. And that is the equation for the graph. So that concludes our 6.1 lesson.